I want to take a look at finding the area between two curves in a vertical way. What I mean by that is consider the parabola y equals x squared plus 21 and the line y equals negative x minus 7. If we want to find the area between these two curves on the interval from negative 7 to 10, what we should do is, well, first of all, draw it out, and we want to look at this area. This is the area that we want to find. That definitely feels like a vertical area to me. And what I would do is first draw what we call a representative rectangle. A representative rectangle is this. I'm going to draw a rectangle in here that represents one of the rectangles in a Riemann sum. And when I look at this rectangle, and maybe I pull it out here to take a closer look at it, we would call the base of this rectangle delta x. And we need to come up with an expression for the height of this rectangle. Well, for any value of x, the height here is going to range between the top and the bottom. In order to do that, I'm going to take the top expression, x squared plus 21, and subtract the bottom expression, negative x minus 7. Now, as a reminder, the important thing about the Riemann sums was that we could draw in infinitely many of these rectangles and add them all together, and it would give us a good approximation of what the area is. And if we drew in so many of them that delta x got basically down to 0, then that would give us the exact area. And earlier we'd seen that the evolution of the Riemann sum turned into what we know as the integral. And so to find that exact area is going to be the integral from negative 7 to 10 of some expression where dx is our delta x, and the expression is going to be the height of our Riemann sum representative rectangle. And if I were to simplify this expression, of course, that would be x cubed plus x plus 28. But now that I have a definite integral to evaluate, that's exactly what we should do. We integrate x cubed plus x plus 28 into 1/4 x to the 4th plus 1/2 x squared plus 28x, and then evaluate it from negative 7 to 10. How we evaluate this is to first take that 10 and plug it into the expression, so we'll have 1/4 times 10 to the 4th, or plus 1/2 times 10 squared plus 28 times 10. Then we'll take in negative 7 and plug that in as well. So I'll have 1/4 times negative 7 to the 4th plus 1/2 times negative 7 squared plus 28 times negative 7. When it's all said and done, this should give us an area of 2,401 1/4. If we want to find the area bound by the two curves of y equals x and y equals 12 minus x squared, we should first draw in a representative rectangle. That should be real helpful in helping us to determine what our integral is. My representative rectangle will have a base of delta x, and the height is going to be the top equation minus the bottom equation. And since the top equation is a parabola, then that value is going to be the 12 minus x squared. The bottom equation is the line y equals x, so I'm going to subtract off x. When we go to set up our integral to find the area, we realize I'm going to take the integral of 12 minus x squared minus x dx, but currently I don't have any limits of integration. I don't know where I'm taking the integral from. So we need to go back and determine where that's going to be. And thinking about our rectangles again, if we were to fill this in with rectangles, our first rectangle would start on the left, and we would continue to fill in more all the way across until we get to the very end. So as far as x values go, I'm going to want the x value from this point and from this point. In order to do that, we need to find those points of intersection. To find points of intersection, we take the two equations and set them equal to each other. So I'm going to take that x and set it equal to 12 minus x squared. This is quadratic. In order to solve a quadratic, I'm going to add the x squared and subtract the 12 from both sides. To get one side equals 0, we factor it into x plus 4 and x minus 3, making my two values x equals negative 4 and x equals positive 3. Those are going to be our limits of integration. So we're going to integrate 12 minus x squared minus x dx from negative 4 to positive 3. Real quickly then, first we would integrate 12 into 12x and minus x squared into minus 1/3 x to the third and minus x into minus 1/2 x squared. Then evaluate this from negative 4 to 3, which is going to mean taking 3 and plugging that in first. So we get 36 minus 9 minus 9/2. And subtract the value we get from plugging in negative 4. So that'd be negative 48 minus negative 64 thirds minus 16/2 or 8. And that will give you a value of 57.166 repeating. If we want to find the area bound by these two curves, we recognize that there are two different distinct regions that we need to take a look at. First we have this region, and then there's this one. So in general, if I wanted to find that total area, I would find the area of that first region and the area of the second region and add those two together. So let's just think about this first region first. And if I look at the representative rectangle, the base is delta x. And as far as the height of this rectangle goes, I notice that over this entire region, the blue curve is on top of the red curve. So I would take whatever that expression is for f of x and subtract from it g of x. That means that the area of this first region is going to be the integral of f of x minus g of x dx. And this extends from this point to this point. So when x is negative 2 to when x is 0. Now for my next region, I'm going to think of another representative rectangle. And over this entire region, again, the base would be delta x, but now the red curve is on top of the blue curve over this entire region. So when I want to find the height of my rectangle, I'm going to take the expression that's on top, now it's that g of x, and subtract from it the one that's on bottom, the f of x. So my next area is going to be defined by the integral where we take g of x minus f of x dx. And of course this region extends from the point 0,2 out to the point 1,5. So my limits of integration are going to go from 0 to 1. And of course, since I haven't defined f of x or g of x, this would be the expression that we would use in order to find that area, but we can't exactly find a value for that area right now.